Now let's solve one more question. Test the continuity of the function f of x at the origin, where function f of x is defined as f of x is equal to modulus of x upon x when x is not equal to 0, and f of x is equal to 1 when x is equal to 0. Now this function f of x will be continuous at origin or at the point 0 if and only the value of this function at 0 is equal to the limit of the function at the point 0, and the value of the function at the point 0 or f of 0 is equal to 1. And now let's find the limit of this function at the point 0. And now when the value of x is not equal to 0, then f of x is equal to modulus of x upon x. And from the definition of modulus function, if x is less than 0, then modulus x is equal to minus x, and it is equal to x when x is greater than or equal to 0. So value of modulus x upon x will vary depending upon whether x is less than 0 or greater than 0. So in order to find the limit of this function when x is not equal to 0, we shall have to find its left hand limit as well as right hand limit. So first, let's find out the left hand limit of f of x at x equal to 0, and which is equal to limit x approaches 0 from the left hand side of f of x, and this limit can be also written as limit h approaches 0 f of 0 minus h, which is equal to limit h approaches 0 f of minus h. And since f of x is equal to modulus x upon x, so the limit h approaches 0 f of minus h is equal to limit h approaches 0 modulus of minus h upon minus h. And now h is a positive number, so minus h is a negative number. And we know it very well that modulus of a negative number is equal to negative of that number. So that means modulus of minus h is equal to negative of minus h, and which is equal to h. So that means modulus of minus h is equal to h. So this expression becomes limit h approaches 0 h upon minus h, or limit h approaches 0 minus of 1, and which is equal to minus 1. And what will be its right hand limit? Now right hand limit at x equal to 0 is equal to limit x approaches 0 from the right hand side f of x equal to limit h approaches 0 f of 0 plus h, and which is equal to limit h approaches 0 f of h, and which can be also written as limit h approaches 0 modulus of h upon h, or limit h approaches 0 h upon h, or limit h approaches 0 1, and which is equal to 1. So the left hand limit is equal to minus 1 and the right hand limit is equal to 1. That means left hand limit is not equal to 1. So that means the limit of the function at the point 0 doesn't exist. And if the limit of a function at a point doesn't exist, then that means this function is not continuous function at that point, which means the function f of x is not continuous at the origin. Now let's solve one more question. Show that the function f of x given by f of x is equal to sin x upon x plus cos x when x is not equal to 0 and f of x is equal to 2 when x is equal to 0 is continuous at x equal to 0. Now in order to prove that f of x is continuous at x equal to 0, we shall first check whether this function is defined at x equal to 0, and then we shall find the limit of the function at the point x equal to 0. And if its limit will be equal to the value of the function at x equal to 0, then only this function will be continuous at this point. Now as per the function, this value of this function at the point x equal to 0 is 2. That means f of 0 is equal to 2. Now let's find the limit of this function at x equal to 0, and for that let's first find the left hand limit. Now left hand limit at x equal to 0 is equal to limit x approaches 0 from the left hand side f of x. Now in place of x we can also write 0 minus h, and when x approaches 0, then in that case h will approach to 0. So now this limit can be also written as limit h approaches 0 f of 0 minus h, and which is equal to limit h approaches 0 f of minus h. And as per the definition of the function, f of minus h is equal to sine of minus h upon minus h plus cos of minus h. So the limits becomes limit h approaches 0 sine of minus h upon minus h plus cosine of minus h, and which is equal to limit h approaches 0 sine of h upon h plus limit h approaches 0 cos of h. Why? Because sine minus theta is equal to minus sine theta, and cosine of minus theta is equal to cos of theta. And now we shall find out the value of the expression limit h approaches 0 sine of h upon h plus limit h approaches 0 cos of h. In the previous classes, you have already learnt that limit h approaches 0 sin h upon h is equal to 1. So in place of limit h approaches 0 sin h upon h, we can write 1. And when h approaches 0, then cos of 0 is equal to 1. So now this expression becomes 1 plus 1, and which is equal to 2. So which means the left hand limit of this function is equal to 2. And now let's find its right hand limit. And right hand limit at x is equal to 0 is equal to limit x approaches 0 from the right hand side f of x, and in place of x we can again write 0 plus h, and when x approaches 0, then h will approach to 0. So now this limit becomes limit h approaches 0 f of 0 plus h, and which is equal to limit h approaches 0 f of h, and f of h is equal to sine of h upon h plus cos of h. So now this limit becomes limit h approaches 0 sine of h upon h plus cos of h, and which is equal to limit h approaches 0 sine of h upon h plus limit h approaches 0 cos of h, and which is equal to 1 plus 1 or 2. So that means the left hand limit as well as right hand limit are both equal to 2. And also, what was the value of the function at x equal to 0? F of 0 is equal to 2. So that means the left hand limit as well as right hand limit as well as the value of the function at the point 0 are all equal. and this is the condition for a function to be continuous at the given point. So that means the function f of x is continuous at the point x equal to 0.